Okay, so we are finally moving on to the second part of calculus, which is integral calculus. We will still use derivatives a lot, but we're going to start talking about something called the antiderivative today. And integrals, we'll use the integral symbol a little bit. The antiderivative is just going the opposite way of a derivative. So if I told you this function f of x equals 3x squared, its antiderivative, which they like to use a capital X for, we'll say the derivative equaled 3x squared. The antiderivative of that is x cubed. The reason that's the antiderivative is if you would take the derivative of x cubed, you get 3x squared. So this x cubed is what they call the antiderivative. That's one word, antiderivative of 3x squared. Actually, that's just one answer. I could have x squared, or x cubed plus 1. I could have x cubed minus 6. I could have x cubed plus pi. I could have x cubed minus 7. I really could have anything there, because remember the derivatives of all these numbers that I'm touching right here are 0. So the actual answer, if I ask you for the antiderivative of 3x squared, is x cubed. So the actual antiderivative, I'll write it down here, is x cubed plus c, where c is some constant. We don't know what the constant is. It could be anything, because remember the derivative of the constant is 0. So that's the basis of antiderivatives. A lot of times they use antiderivatives with that word differential equations that we used last week. So like if I gave you this differential equation dy equals 2dx, and they want you to find the antiderivative of that, or they want you to find the general solution. The general solution to a differential. So this was a differential equation that we talked about last week, because it's dy equals 2dx. So if I'm going to find the general solution, to find the general solution, I have to find the antiderivative. Well, you guys have done a lot of derivatives. The antiderivative of the number 2 is 2x. So that's the antiderivative, plus some constant. It could be any constant, so I say c. So this, what I wrote here in blue, is the general solution to this differential equation, 2x plus c. Because if you take the derivative of 2x, you get 2. So that's the differential equation. This is the general solution. Now, when we start talking about general solutions and antiderivatives, we actually get into the integral symbol. An antiderivative and an integral are the same thing. So this is an integral symbol. It's like a big S. And usually you take the integral of some function, f of x dx. And that dx has to be there because you're differentiating, you're taking the integral, of a differential equation. So this part right here, the f of x, is what they actually call the integrand. This dx, remember how I said that was the small change? That's your variable of integration. And then this symbol, like I said, this kind of tall, skinny s is just an integral symbol. That symbol means that you're going to integrate or take the antiderivative. They're the same thing. An integral actually has more of a definition than just an antiderivative, but for today we're just going to say it's just an antiderivative. So if I find this, the integral of f of x dx equals f of x, the antiderivative f of x, plus c, and remember c is that constant of integration. It could be any constant, any number. Let's look at some basic rules for integration. We look at these a lot. They're kind of like the rules of differentiation, but backwards. Actually, before I do that, let me show you something real quick. If I'm going to integrate, let's say I'm going to integrate 4x cubed minus 1 over x squared dx, and I tell you that that equals x to the 4th plus 1 over x plus c. So I'm giving you the answer. How can you make sure that's true? So how is that true? What you can do without knowing any rules of integration is you can take this and take the derivative of that. So I'm going to take the derivative of this, and the derivative of that is 4x cubed, and then that, remember, this is x to the negative 1 if I move it up there, so minus 1 over x squared, and the derivative of the constant is 0. So is that true? Absolutely, that's true. That's how you could check without knowing any rules of integration. You could work backwards to check. Alright, so let's now try some basic rules of integration. I'm only going to go through a couple of them. We'll do more tomorrow. So basic rules of integration. I would write these down. We'll memorize them eventually, but for now you want them. If you take the derivative, I'm going to go back to derivative for a second so you can see the difference. The derivative of a constant equals 0. Remember that? Okay, so if you integrate 0, that equals a constant. If I take the derivative of kx, so some number times x, so 4x, the derivative of that was just k. If I integrate k by itself, dx, if I integrate that, I get kx plus some constant. So if I take the derivative of kx right here, I get k. So if I work backwards, if I start with just some number like 4, I get 4x. So what that means is right here, if I have 4 dx, if I integrate that or take the antiderivative, I get 4x plus some c. Where what we've done before, we always said the derivative of 4x is 4. So you can see how you're just kind of working backwards with them. Alright, let's try a couple more. Oh, if you have, this one we use a lot, some constant times a function. Remember, the derivative of that was the constant times the derivative of the function. You don't take the constant, just stays there. And when you're integrating, what you can do, and this is a rule we use a lot. Whoops, I just wrote that wrong. I have k times f of x dx. What I can do is I can rewrite that and put k out here in front of my integral symbol. And as we start doing problems, you're going to see that that makes that easier. Okay. If you have, I'm just going to stick with these because these two are kind of basic. If you have f of x plus g of x dx, like you're adding two functions together, when you integrate them, you can also make that the integral of f of x dx plus the integral of g of x dx. So you can add them like that and break them up into two parts. Alright, this next one, I'm going to go back to differentiation for a second. If you have 4x cubed, and you're going to take the derivative of that, that gave you, you moved the 3 in front, right? So you had 3 times 4, so 12, and then you subtract 1, 3 minus 1 is 2. Or in general terms, with derivatives, if you had just x to the nth power, remember we moved the n in front, so we get nx raised to the n minus 1. So if you're integrating, we also have something called a power rule for integration. And this one we use quite a bit, just like we use the power rule in differentiation. If I have x to the n dx, the power rule says, opposite of what we did over here, where we multiplied and subtracted, we have to add. So you get x to the n plus 1, so you're doing the opposite, and instead of multiplying, you divide by this n plus 1 power plus some c constant. There's always that c constant for now. So this rule, the power rule, is one we use a lot. I'm just going to show you a couple quick examples. If you have 1 over x cubed dx, you're going to integrate 1 over x cubed dx. I'm going to rewrite that as the integral of x to the negative third dx. Alright, so to get my answer, I'm going to use the power rule. I'm going to have x to the negative 3 plus 1 divided by negative 3 plus 1 plus c. So that becomes x to the negative 2 over negative 2 plus c, which is just negative 1 over 2x squared plus c. And if I want to make sure that's right, if I take the derivative, I should end up with my original problem over here. Alright, another one that you'll see quite a bit is like 1 over x times the cube root of x. If I'm going to integrate that, I need to rewrite it as the integral of 1 over, this would actually be x to the 4/3. It's a little trick that we use because we're going to add those power 1/3 plus 1. So that's the same as the integral of x to the negative 4/3, which is going to be, if I use my power rule, x to the negative 4/3 plus 1, all divided by negative 4/3 plus 1 plus c. So that gives me x to the negative 1/3 over negative 1/3 plus c, which is going to be negative 1 over 3x to the 1/3 plus c. Okay, that's the power rule, and if you take the derivative of this, you should get this, or this, whichever way you had it written. Okay, so that's kind of the basis of the power rule. You guys you're going to try a few of these today with the power rule, and we will try more with integration tomorrow in class. Okay, so check Canvas for the assignment.